Hello. Now that we know how to do prime factorization, we can use that to simplify radicals, so square roots. So on example 1, I have the square root of 50. If you do the square root of 50 in your calculator, you will get a decimal. So let's see if I can pull up my calculator here. Nope. All right. So, if you do the square root of the square root of 50 in your calculator, you get a decimal, meaning that 50 is not a perfect square. Like how 100 is a perfect square, or 25 is a perfect square, or 9 is a perfect square. Because the square root of 100 is 10, or the square root of 25 is 5, and the square root of 9 is 3. These are all perfect squares. Right? There's no decimals. But if I look at the square root of 50, that's not a perfect square. And so we want to be able to simplify this. To do that, I'm going to use the birthday cake method. So I am going to put 50 at the base of my cake. The smallest prime number that goes into 50 is 2. 2 goes into 50 25 times. The smallest prime number that goes into 25 is 5. 5 goes into 25 5 times. The smallest prime number that goes into 5 is 5. 5 goes into itself 1 time. When you get to 1, you're done. 1 is the candle to your cake. Because this is a square root, square means 2. So I'm looking for pairs of numbers to be able to leave the square root symbol. Well, here I have a pair of 5s that can leave the square root symbol. So 5 is going to become my coefficient. 2 does not have a pair. So 2 is going to stay inside the square root symbol. So that means that the square root of 50 simplifies to 5 square roots of 2. That is my answer. Let's try that again with example 2. With example 2, you'll notice that I have a coefficient of 3 out in front. So 3 is automatically going to be a part of my answer because it's a coefficient. And so I'm going to write down that 3 so I do not forget about it. Now I'm going to do birthday cake for the square root of 80. The smallest prime number that goes into 80 is 2. 2 goes into 80 40 times. The smallest prime number that goes into 40 is 2. 2 goes into 40 20 times. The smallest prime number that goes into 20 is 2. 2 goes into 20 10 times. The smallest prime number that goes into 10 is 2. 2 goes into 10 5 times. And then 5 goes into itself 1 time. When you get to 1, you're done. 1 is the candle to your birthday cake. I am looking for pairs of numbers to leave the square root symbol. Here I have a pair of 2s that can leave. This pair of 2s is getting multiplied by the coefficient of 3 that was already out front to begin with. Then you'll notice that I have another pair of 2s that can leave the square root symbol. So they will also get multiplied. This 5 does not have a pair. So that 5 is going to stay inside the square root symbol. So now I need to multiply. 3 times 2 is 6, times 2 is 12. So my answer is 12 square roots of 5. Let's try that process again with number 3. So on example 3, I have this coefficient of 6 that's out in front. So I'm going to go ahead and write down that 6 so I do not forget about it. Now I need to do birthday cake for 8. The smallest prime number that goes into 8 is 2. 2 goes into 8 4 times. The smallest prime number that goes into 4 is 2. 2 goes into 4 2 times. The smallest prime number that goes into 2 is 2. 2 goes into itself 1 time. When you get to 1, you're done. That's the candle to your cake. I am looking for pairs of numbers to leave the square root symbol. Here I have a pair of 2's that can leave. This 2 does not have a pair, so that 2 is going to stay inside of the square root symbol. 6 times 2 is 12. So my answer is going to be 12 square root of 2. What I would like you to do is go ahead and find the answer to number 4. So pause the video and then try number 4. There are 2 ways that you could do example 4, and let me show you what they are. If you didn't recognize that 400 is a perfect square, then you probably did the birthday cake method. So let me go ahead and begin by doing that. The smallest prime number that goes into 400 is 2. 2 goes into 400 200 times. The smallest prime number that goes into 200 is 2. 2 goes into 200 100 times. The smallest prime number that goes into 100 is 2. 2 goes into 150 times. The smallest prime number that goes into 50 is 2. 2 goes into 50 25 times. The smallest prime number that goes into 25 is 5. 5 goes into 25 5 times. And the smallest prime number that goes into 5 is 5. 5 goes into itself 1 time. When you get to 1, you're done. That is the candle to your cake. So here I'm going to be looking for pairs of numbers to leave the square root symbol. So I have a pair of 2's that can leave. And I have another pair of 2's that can leave. And I have a pair of 5's that can leave. I don't have any numbers left over, so there's nothing left inside the square root symbol. 2 times 2 is 4, times 5 is 20. So my answer is 20. There are no numbers left over, so I do not have something inside of a square root symbol. When this happens, that means that you had a perfect square to start with. The square root of 400 is 20. And some of you might have been able to see that right away because you knew that 400 is a perfect square. If you didn't know that, that is okay. You can do the birthday cake method. And when you get no pairs or no numbers left over from your pairs, that means that you have no square root.